problem number 2e, now we're creating yet another new function called h of x. H of x is also built by using that f of x function. This time, instead of multiplying by a 3, we're multiplying by a 1/2. So I'm going to do 1/2 times the f of x function. The f of x function was x cubed minus 4x. I'll distribute again to clean this up. So I'll get 1/2 x cubed. And then half of 4 would be 2. So this will be minus 2x. So there's my h of x function. We want to put that one in the calculator and also compare it to that original function. So I'll go back to the y equals, go down to that y2 line. Let me clear that out. And now instead, I'm putting in 1/2 x cubed and then minus 2x. And let's graph that one. That new one will come up in red again. And so again, how did the blue graph change? I do think kind of focusing on this hill and this valley is helpful. This time it looks like somebody squished it down as if they pressed from the top and made it lower than before, or on this piece as if they pushed up from the bottom. But the entire graph seems to be compressed in a vertical manner, and that's exactly what's happened. So we say that new graph compressed vertically, and let's see, did it compress by half as much, a third as much? How did that work? Well, we multiplied all the y values by 1/2. They're all 1/2 as much as they used to be. So it compressed vertically by 1/2, a factor of 1/2. You can see that on the graph. It certainly looks like this top point was around 3, and now it's around 1.5. It's been cut in half. All right, and then in part H, we have a new example we're looking at. So this is not connected to the previous problem. We have this new function called g of x equals x squared minus 4x. I'm going to create another function called m of x. M of x is just the negative of this new g of x function. So the negative of x squared minus 4x, when I distribute that negative sign, I'm going to end up with negative x squared and then plus 4x. I'm going to put those two functions, that g of x function and the m of x function, into the calculator, and then we'll compare the two graphs. Okay, so back to the y equals. Let me clear everything out. And on the first line, we will put in the x squared minus 4x. Squared does have its own button. And then the second function was negative down here, negative x squared plus 4x. So what happens when you do the negative of a function? The original one is in blue, and the new one will be in red. Aha, this one's pretty easy. It looks like somebody just took that blue one and turned it upside down. Instead of being an upward parabola, it's now a downward parabola. The fancy word for that is reflection, and since it happened up and down, it would be a vertical reflection. Notice that the mirror line, so to speak, the line across which the graph reflected, would be this x-axis right here. Everything above the x-axis went below, and everything below the x-axis flipped above. So we'll say it reflected vertically across that x-axis. In problem number 3, we'll put this all together. So let's say we have a function called p of x. We're not going to give the equation for it. Let's use what we've learned here to write an equation for each of these new functions in terms of p of x. In terms of p of x means I'm being asked to write something like this. I'm not being asked to write an actual equation, just something in terms of p of x. Okay, so the first example, r of x is formed by vertically compressing the p of x function by a factor of 1/4. Well, we learned that the vertical compression happens when you do an outside multiplication by that fraction number. It was the second example that we did in number 2. So the answer here must be 1/4 times p of x. Letter B, s of x is formed by vertically reflecting p of x across the x-axis. That was the third example we did in number 2. That was the one that happened when we made the original function negative on the outside. So if you did the negative of p of x, you'd get that vertical reflection. And then t of x is formed by vertically stretching p of x by a factor of 12. That was the one where we multiplied on the outside by that number. So if I did 12 times p of x, that would result in that vertical stretch.